You guys have any questions from the homework? Yeah.
I have 3 questions again.
From chapter 10?
Number 10, 14, and 17.
From chapter 10?
Chapter 9.
We've done number 10 before. I'll try it again though. Yeah. Alright, we'll do it. What's the other one? 14? Okay. And 17. Okay. No, we didn't do number 10. Alright, sounds good. Sort of set you up for what's going on with number 10 here. You have 3 different boxes. What I'm going to do, I'm going to start a new one. Okay. 3 different boxes. Let me go ahead and take this question and copy it. Put it on the slide. So, let's talk about this question. 3 boxes, black and white balls inside the boxes. The following breakdown. Yours might have a different breakdown, but setup is the same. You're going to draw a ball from box 1, put it into box 2, draw a ball from box 2, put it into box 3, draw a ball from box 3. Part A says, well, what's the chance that the last ball drawn, the one that's drawn from box 3, is white? Yeah. So, actually, I don't think we need it. I think I did it before with someone, and I used a tree diagram. I don't think we need one though. So, what's the chance that the one drawn from box 3 is white? Okay. One drawn from box 3 is white. But we got to draw one from box 1 and draw one from box 2. And so there'll be different ways in which this can happen. Here's one way where we have they're all white. Here's another way where the first 2 are black and the last one's white. And then finally the last, actually no, there's 4 ways. Maybe a tree diagram might be helpful. Black, white, then white. And then finally white, black, then white. Maybe a tree diagram might be helpful. Okay, this is half of the options. There are 8 different options. Yeah. Let's go with the tree diagram then. White or black for the first one. White or black for the second one. And then finally white or black for the third one. Off each one of those we have white or black. And that list I just made up there, that's all the routes that end in a white. All white, 2 blacks and a white, black, white, white, and white, black, white. Sort of half the routes. The other half end in black. So how do we get the probabilities? Well, box 1 has 5 balls in it, and 3 of them are white. So you have a 3 out of 5 chance of getting a white. I really messed that drawing up. Is there any way to undo what I did? Oh, nice. With all those route drawings, I messed it up, but now we're good. Okay, so, yeah, 3 out of 5 for white and 2 out of 5 for black. Now here's the key. When you take it out, you're going to put it in the next box. It's going to change the numbers. You have 8 balls in the second box here. By you taking one, you're going to make 9 balls. If the first one that you took out was white, then the breakdown is going to be, you no longer have 4 white, now you got 5 white. So you got a 5 out of 9 chance for white and a 4 out of 9 chance for black. But if the one you took out was black, then it just flips to be that there's actually now 5 black. So you got a 5 out of 9 chance for black and a 4 out of 9 chance for white. Take that ball, put it into box 3. Now box 3 has no black at all. If you took a white out and put it into box 3, there's no blacks. You're guaranteed that what you pick out is going to be white. It's a 1 probability and 0 probability. Same thing down here. If your second ball was a white, then you're guaranteed that your third ball is going to be white. If you want to put like 1 out of 1 or 100% or something like that, I don't know. I just think 1 and 0 is good. And then, if your second ball is a black, you go and put it in here, the breakdown changes where now it's a 50-50 chance because that 1 black that you're getting is now going into here. So it's a half-half chance. Okay, and then you just multiply the probabilities for these 4 different routes that are guaranteed to end in white, and add them up. I'm sorry, I didn't say that. Get the probability of 3 whites, add that to the probability of all the other guys. So it's a bit of a hassle to go through all this mess, but that's what this question requires. That's only part A. But once you're done, though, you think about part B, and the way they word it, it seems like whatever you get for part A, take your answer to A and subtract it from 100%, or if you want decimals, what they want? They want the fraction. So 1 minus your answer from A will be your answer from B. It's either going to be white or black out the third box, and part B says what's the chance that it's black out the third box. Part A says what's the chance it's white out the third box. So they'll add up to 100%, or the 2 fractions will add up to 1. So with my numbers, the ones that are in this particular problem, the 2 answers are, I erased them, let me go back to the, so if you want to work it out with the numbers I have, I get 34 and then 11. 34 out of 45 and 11 out of 45. I'll just put them on here for you. That this is equal to 34 out of 55, and the other one's 11 out of 55. 45, sorry. 34 out of 45 and 11 out of 45. Okay, so work that out and make sure that you get that, and maybe if your numbers are the same, then you're done. If your numbers are different, just see how it's going to make small changes for yours. But that is question number 10 from chapter 9. good with that? Here's question number 14 from Chapter 9. Just give me a second to go through all this business again with the getting the slide picture. Is this a multi-part question or just a single-part question? Anybody know? I think it's just a single part. I don't know for sure. I'm going to go with the idea that it's just a single-part question. If the bottom it says 3 parts remaining, all right, we answer this part, then that's the only time that the second part pops up. That's okay though. Alright, my numbers might be slightly different than yours again, but it's okay. Suppose you draw a card from a well-shuffled deck, 52 cards, standard, cards that we've been talking about. What's the odds? Okay, I guess all the questions are right there. What are the odds against drawing a 5? Okay. So this is the 4-part question. I really don't need that. Oh, they wanted us to 1. Okay, maybe we did need that. Okay. Alright, so what do? We odds against something. How do you do that? Odds against? The way we do it, we set it up as a ratio where we have what's the 2 sides of the odds against when we set it? What goes on this side? What's on that side? How do you find odds against? What does odds work? Nobody knows? Test next class. You should know. I'll wait for an answer. Look it up if you don't know. Should be in your notes. Yeah. Got a good start. Unfavorable. And then with the dots, you don't put the total, so it's unfavorable and favorable. Very good. The total comes in when you go to probability. So unfavorable and favorable. Okay. So there's 52 cards, and they want to know unfavorable and favorable for drawing a 5. So of the 52 cards, favorable to drawing a 5, there's 5 of them. Unfavorable to drawing a 5, 48 of them. Now here's the problem though. They're trying to force you to put the ants in a certain kind of way. Oh, duh. Sorry. Thank you for catching that. What happened to 4 cards? Oh, we're at 5. I guess 5. They got thrown off. Alright. 48 to 4. Great. But they don't want that. They want something to 1. When you have a ratio like this, you can divide both sides by the same number and you get what's an equivalent ratio. And so they want you to divide this by 4 and divide this by 4 to give the answer kind of, I guess, in lowest terms. It's kind of what they want you to do, I guess. So we get a 1 That's the one that they want. And then 48 divided by 4? 12. So 12 to 1 is the answer. Just double check. Well done. Well, if you're 12 to 1 against, then you're 1 to 12, 4. Great. And then they go through a different situation. They're being specific here. They say not just a 3, but a black 3. So, just write this one here. Odds in favor. Drawing a 5. Would be 1 to 12. Odds against. Drawing a black 5. I'm drawing a black 3. Jeez. Set it up again. Unfavorable to favorable. Sorry about that. Unfavorable to favorable. How many black 3s are there? 2 of them. Leaving 50 cards that are unfavorable. But, once again, I think they want it to 1. So, 25 to 1. I gotta double check it though. Make sure that's what they want. Is that what they want? Yeah, to 1. So we're saying it's 25 to 1. Good. And then flip it. 1 to 25. Okay. That one wasn't as bad. Alright, good stuff. That was number 14, chapter 9, on the online homework. And the other one was number 10. Chapter 9. Sounds good. And your third question was number 17. Suppose it costs $14 to roll a pair of dice. You get paid $2 times the sum of the... Oh, yeah. It's a long question. $2 times the sum of the numbers that appear on the dice. What is the expected value of the game? Is it a fair game? Let me show you the setup. It's kind of long and involved, but it's okay. Print the screen. Go here. Paste it. Cut out the part I want. Go to here. Add a slide. Paste it. Make it bigger. Okay. With this one, we have to. I guess we've maybe scratched the surface of this whole rolling die thing. Rolling 2 die. You have this. One die could be 1 through 6, and the other die could be 1 through 6. So there's 36 different options. And what they want us to do with these two different numbers that come up facing is they want us to add them together. We're going to take the sum of these numbers. So the sum could be a 2. The sum could be a 3. The sum could be a 4. The sum could be a 5. All the way to the sum being 12. That's what makes the problem long, because of all the different, when you go to find expected value, you got to start out with the net outcome. And what we're saying is that there's 12 different net outcomes. Seven shows up 6 different times. And then 8 shows up 5 different times. And so on. Anyway, so yeah, the outcome would be what you doubled what the sum is. So if the sum is 2, you double that, and you get a 4. And that's how much money you're going to get back. You're going to pay $14 to start the game. Then they're going to give you some money back. But if your sum is 2, you're only getting $4 back. So the net outcome would be that you lose 10. Right? If your sum is 3, you're going to get $6 back. You're going to be losing 8. Sum is 2, sum is 3, and so on. There'll be a pattern that you'll see. You can break even if you roll a 7. If you roll a 7, you'll get $14 back. You'll be breaking even. And then it goes that you start getting money. All right, if you roll an 8, you'll be walking away with $2. Here's the ... part of it. I'm running out of room. Well, how do you find expected value? After you got the net outcome, then you multiply that by the probability of that happening. What's the chance? And what's going to happen here basically is that there's a symmetry going on. All these negatives will balance out with the positives because they have the same probability. The chances of getting a 6 are 5 out of 36. The chances of getting an 8 are also 5 out of 36. So the outcome of $2 will balance out with the outcome of negative $2. And so on. And so it's going to be, the answer is going to be, the expected value of the game is 0. And yes, it's a fair game. I know that looks like a 10 there, but yeah, it's going to balance out. Finish it out though. Write out these probabilities. On the test, we'll probably want to see it all. It's a little bit involved for a test though. Too many outcomes, I believe. But anyway, when you multiply x times p of x and add them all together, they're going to balance out. It's going to be zeroed out. This negative 10 out of 36 will balance out with this positive 10 out of 36. This will be zeroed out. 6 out of 36. Keep it all out of 36, although, you could reduce it. But some of these you could reduce. Leave it like that, and you'll get this balancing happening. 4 ways to get a 5. 4 ways to get a 9. So this negative 16 out of 36 is going to be balanced with this positive 16 out of 36, and so on. Sorry, I don't write the whole thing out. Hopefully that's okay. Who's the person that asked this? Is that okay?
Yeah, I did this, but she said I kept getting the right answer.
The answer is 0. I don't care how the numbers come up. I think the answer is 0.
The numbers were different.
Well,
And I read the word that she said not working.
you put 0 in and it got it wrong? You're saying,
I didn't get 0.
I'm saying that I think they have it set up where it's going to be 0 no matter how they pick up the numbers. So, well, I don't know. Try it out. You got the setup. Try with your numbers now. I thought it was going to be that it's going to be 0 no matter how they switch up the numbers, but I guess I could be wrong with that.
I have it's playing on 2 roll dice, you get $3, and I hit 0.
0. I think they set it up that way on purpose. So whatever the how much it costs to get the game, divide by 7. That should be how much it'll pay you back. And so go ahead and just put the answer 0 in, and then this is what. Well, you had $22 to pay the game? You said 22? Oh, yours is different then. If you have no, I'm saying if you have 22 and you get paid 3 times the sum.
Well, that's like I tried it like multiple times. That was what it was.
Yeah, so 0 is not going to be your answer.
Right.
Okay.
It doesn't work out to be 0 every time.
So yours doesn't have this balancing. But hopefully I've given you the framework to be able to answer the question correctly now with your numbers. The probabilities won't change. These numbers here will change for you. So I just need you to get the right numbers here. Keep these probabilities as they are. And you'll be able to get the right answer. It won't balance out. You won't get this balancing like I do and like what she did. Yours won't balance out negatives and positives. But still should be doable. Just if your game costs $22 and you're getting paid, how much you getting paid back? $3 times the sum.
Yes.
$3 times the sum. Yeah, I'm thinking that. You just change these numbers right here to address that, and keep these same probabilities, and your answer should fall out of that. Pretty sure about that. You roll a 2, you get $6 back. You paid $22 to play the game. Your first number here is negative 16. Yep. And I think it's just going to go up by 2s. Oh, 3s. For you? 3s. You roll a 3, you get $9 back. Negative 13. Yeah, so that's what you're going to get. Your number here is going to be negative 13. Your number here is going to be negative 16 here, negative 13 here for your setup. And it should come out. If this is a 22 and this is a 3, then this will be a negative 16, and this will be you'll get $6 back, so negative 16. You'll get $9 back, so negative 13, and so on. Just keep adding 3 to that. Negative 10.
I think it was when I got down to 8, because I have negative 16, negative 13, negative 10, negative 7, negative 4, negative 1, and then
Positive 2?
8 is 24, and then so you have $2.
Positive 2 there, yeah.
So that's where it doesn't cancel out.
That's good though. So just now multiply. You know what I mean? Like take your numbers, multiply, get the products, and add that whole column up on this side, and that'll be your answer. I mean, you got everything set up. You just got to finish it out. Negative 28 here, negative 4, negative 1. So you don't, you get the things that are in black.
So it's not going to go down to 0 every time?
Not for you.
That's what I just thought. It was supposed to go down to 0.
I assumed that too. I'm sorry about that. That would make the most sense. But they didn't make it that way, sorry. But as long as you have this set up right, then it's okay. Just know that your numbers are just slightly different, but your probabilities are exactly the same. And then just multiply here. X times B of X. Anything else? Alright, so we just need to finish chapter 10. Well, not all of chapter 10, just part of chapter 10, 10.3. But not even all of that, just part of that. Let me give you this thing to help you take notes. Mean, median, mode, and box plot. We'll go all the way to box plot and stop there. Do something to double check something. There's 30 chapter 10 problems. What was it? I'm going to have to take some of these off. Okay. Looks like the last few of these are going to have to come off. Alright, 27 on looks like they're going to come off. No, 25 is going to. Okay, looks like they're probably, the last 10 are going to come off. Not for this test, we just don't have the time to finish by the time we get to this test. And I'll make sure that we pick it up for next test, but we're going to stop at number 20, it looks like. I'll shave off the last 10 problems here. Mean, medium, mode, that's okay. Number 19, it's okay. 20, box plot, that's okay. Just skip around. Alright, we're good then. So it's just 21 on. I'll take those off. We won't get to those. I mean, we might get to them next time. So let's just say that I'll take them off. Standard deviation. That's where standard deviation starts, with number 21. So let me take those questions off. I guess there might be some way I could shift them on to the next assignment. I don't know how. All of them? Alright. Well, we'll figure it out. It'll be some grand total, so then you won't have to do them for the next time. Yeah. So let's just do this. I'll leave them there. Just know that for this test, only go up to 20. I'll extend the deadline or something like that, so that let me see. So we're saying that you've already done them. I want you to get credit for doing them. So let me just extend this deadline. But by this test, you know, you should go up to 20. So I will settings for the class. I'll change this to be extended, so that you guys can go and do 21 through 30 once we learn it. Extend it like a week or so. Why are these things cutting off today? Oh, because originally the test was supposed to beat it. Yeah, okay. So first off, let me say that this needs to change anyway, with the test not being until Tuesday. So that's good. Now I'll extend it even further than it should have been extended, say till a week after that. So on the 6th, we're going to go over that material. I don't know, let's just go to the 18th. But just know that you should do 1 through 20 to get you ready for the test. That sounds good. And that way those people don't get cheated.
Why did you change chapter 9 into 4?
Yeah, it's unfair to have these things cut off like this. If the date of the test changed, then the date of the homework due should be changed. Yeah. Good stuff. Alright, we're good now. That was due on the 4th, the other was due on the 18th, but just because of the last 10 problems. Before the test, try to go through 1 through 20 though. Alright, great. So the very last part of 10 that we're going to be able to get a chance to go through today, Chapter 10, Section 3. Just this first one here. Computing the means, median, the mode, and being able to find a box plot. Trying to figure out what's the best measurement is correct. Measurement is simple. Those three, mean, median, mode, do that for certain data sets. that, yeah, where are we at here? So this next slide, that'll come later. That's the rest of that chapter 10. That's the last 10 problems. They come from this last slide here. But 1 through 20 come from the first slide. They should definitely. And so I'll do a double check on that though. But try to go through 1 through 20 before the test. These standards, we don't have to know those. You're interested in measuring center and spread. For us, we're just going to talk about center now. The other stuff is talking about spread. We'll wait for that. How do you measure center with the 3 M's, the mean and the median? Okay. They describe where the center, they're measurements of the central tendency of the data set. And then these other ones down here, we're not going to worry about those till next time, but here they are. They're measurements of spread, range, interquartile range. These will come up for us now, but then these other ones, variance, mean, absolute deviation, standard deviation, that'll be next time. But range and interquartile range, they'll come up because they help us get the box plot. That's how it measures how well the data is spread out. Okay. So it's about center being the mean and the median. A third measurement here is the mode. It's not as often used to measure the center, so they left it out of this statement, but I think they should have put it in. Okay. Mean is the average. Median is the one that's in the middle. And mode, the one that's not on this list right here, is the one that appears most often. It'll come up in another slide, though. Any questions about that? All right. So the mean is just add them up and divide by how many you have. Fancy word is actually arithmetic mean. I just say call it the mean. The symbol for it is an X with a bar on top of it. And you say X bar when you say it. Add them up and divide by how many you have. So we know about that. This is just a graph to show you how this is actually a measurement of center. It kind of measures the balance. This is a dot plot here. Remember we did those last time? And it isn't just because 5 is in between 0 and 10. It's that it's the goal is to be able to balance the numbers from one side to the other. And so it's not that there are 4 on this side and 2 on this side, not that kind of a balance. But that basically the sum of these will balance with the sum of those. Where you would place it at so that the things would balance out. Not the sum of the numbers, but the sum of how far these numbers are away from the mean. It's not like we're adding 2, 3, 4 together and trying to get that to add up to 18. What we're saying is this one's a distance 1 away from the mean. These two are a distance 2 away from the mean. And this here is a distance of 3 away from the mean. This is a distance of 5 away from the mean. This is a distance of 3 away from the mean. So it's about balancing how far you are away from the mean. The ones that are below balancing with the ones that are above. Yeah. 1 plus 4 plus 3 is 8, and 3 plus 5 is 8. 1 away, 2 away, 2 away, and 3 away. So that's how they get the. Not that you would ever have to do it this way. I guess they just want you to see the connection. This is 1 away. This is 2 away. This is 2 away. This is 3 away. That sum will balance with this sum when the mean is right in the middle where it should be at here. Different numbers, you'll get a different setup, but not that we would ever think about mean that way, but they just want you to see how center, they really should have had it not at 5, because 5 being right in the middle. Center for average is different than center for median. So the 1 plus the 2 plus the 2 plus the 3 is 8. And the 3 plus the 5 is 8. The data are centered about the mean. The mean isn't a part of the data set, but it could be. They don't say that. Okay. And then they just go on overkill with this, but it is possible to rearrange the data to have the same mean, but the spread be very, very different. So here's one data set, and here's another data set. And so these numbers add up to 30, and when you divide by 6, you get 5. These numbers add up to 30. When you divide by 6, you get 5. So there's a big difference in saying what the center is and saying what the spread is. Just because the center is the same, how far apart these are spread are very, very different. And so once we get the spread, which won't be today, we can see that there's a measurement of spread called standard deviation, and these two have very, very different standard deviations. Okay. But the median is the other center measurement that you use. It's the one that's exactly in the middle. So make sure you just arrange the numbers. You don't have to do it from least to greatest. You actually could do it from greatest to least, but by convention, people say do the smallest first, all the way through the largest. They have to be ordered so you can tell what falls right in the middle. If they just a randomly scattered around list of numbers, then you can't say which one is in the middle of the data set. You have to order them first. And then it's going to be different if you have an odd number versus an even number. If you have an odd number of them, then there actually will be one of the numbers from your data set will fall right in the middle. For example, if I have the numbers 1, 4, 5, 7, and 11, that's an odd number. There's 5 total numbers there. There's always going to be exactly one of those right in the middle. And so that would be the median of that. It gets a little bit different, though, if you take and have, that's supposed to be 1, 4, 5, 7, 11, and 16. It's different when you have an even number. If I have an even number, then exactly in the middle, I have both of these guys kind of in the middle. So what do? I take an average of those. 7 plus 5 divided by 2, or the one that's in the middle of between those two would be 6. Okay, so it's handled differently whether there's an odd or an even number in the data set. It's nice when there's an odd, because you don't have to do any math after that. You just find out which one is right in the middle. When it's an even, you just have to do a little bit more. Take an average of the two that are in the middle. Okay. They go into this interquartile range because we needed to do a box plot. It really is a measurement of spread, and spread is sort of going to be what all the other things are, but it's closely related to median, and so that's why they went right into it next. The interquartile range basically will be essentially the difference between two medians. You cut your data in half, and you have a lower half and an upper half, and then you get a median. You get a median for the lower half and a median for the upper half. And this IQR, this interquartile range, ends up being the middle 50% of the data. Okay. We're going to calculate it, of course, for a data set, but that's what it means. And they say that it's a better measurement to have those two numbers as opposed to the median by itself. Mode, that's the one that appears most often, most frequent. But it's not the best measurement of central tendency. It's useful, but not the best. So it's the one that appears most frequently, if there is one. It could be multiple ones. But it's probably not the best thing to do to say that it's going to tell you what the center of the data set is. That's why they left it off of that list. I just think of 3 M's always coming together. In that list, they only had median, and mean. Okay. But if you have categorical data, then actually mode is going to be used, because it's not about numbers at that point. It's just about categories, and you want to know, well, what category has the most numbers in it, and that's when you would go with mode. But for us, we're talking about numerical data now, so we're just going to go with the mean and the median as the measures of center. Okay. Simple data set: 60, 60, 70, 95, 95, and 100. What's the mean? Add them all up. Divide by how many you have. So what is that for us? There's a way to do it on your calculator where you don't have to do it by hand like this. But since the graphing calculators aren't part of it, I won't go through this showing you of it. Scientific is enough for this class, so this is what you would do. Add these up, divide by how many you have. You don't have the total yet? 80 is the answer. So that makes the total 480. People getting the same thing? I didn't do the math. Okay. It's already listed in order from smallest to largest. That was nice of them. But there's 6 data values, so both of these are in the middle. So when it comes time to calculate the median, we have to take an average there. Right in between 70 and 95 is 82.5. That's a lie. 77.5. Jeez, what is it? 82.5? Okay, good. Don't try to do it in your head like I just did. Letter C, which one is most often? $60 shows up twice, and 95 shows up twice. So they're both the mode. Okay, when you have more than one mode, for some reason they throw the sort of Latin prefix in front of it. So this is bimodal when you got 2 of them. Okay, so we know we use the mean most often to say what the center is, what the average is, but sometimes it's a bad measurement. If you throw in some extreme value, the mean is going to be greatly affected by the extreme value. Here's a setup. You got 20 people working for a company. The president is the extreme value. How much the president makes? $200,000. That's the extreme value. The vice president isn't as extreme. Vice president making $75,000. But you got 18 employees only earning $10,000. If you do an average on that, then what you'll see is that the average is it should be somewhere 10,000, because you have all these people, 18 out of 20, only making 10,000. But just 2 values, but mostly the one value, the 200,000. These 2 values are dragging the average away from where the center should really be at. So the average would be a bad representation of center for this data set. Add them all up. The way it's set up, you have 18 of these 10,000, and then these 275. That's 455,000. Divide that by 20. And it's saying that the average is 22,750. But by no way should that be a number that you would use to say what the center of the data. I mean, it is the average, no doubt, but it's greatly affected by the extreme values. And so maybe you should, in this case, actually, I know we said we don't use the mode too often, but the median would be the one to use here. If you list all those, guaranteed that 10,000 will fall right in the middle, because you have 18 of these 10,000s and only 2 of these other numbers, so 10,000 definitely falls right in the middle if you were to list them. All 18s of these 10,000s, and then the 75,000 and the 200,000. So halfway in between would definitely be 10,000. So the median is a whole much, when it comes to salaries like this, or how much a house is worth or something like that in your neighborhood, people actually rather use median than mean. Okay. It's because the mean is affected by extreme values, and the median isn't. You add an extreme value to a data set, like adding a whole nother, like making it seem like your biggest number is 100 more than all the rest of them, or 1,000 more. It doesn't affect what's in the middle. So the median isn't affected by extreme values. Okay, here the median is a bad representation. If you do the median, this is there's 9 test scores, so the one that's the 5th is the median. So that'll be this guy right here. That's the median. But if I wanted to use that as a number to say something about the data set, that would be a bad number to use. All right. Looking at these scores, if I used to say the center is 92, you would think then that things are spread out differently than they are. It's misleading to try to use that number as the measurement of center, and maybe it's in this case then that we want to use the average, as in the mean. So the median is 92, but the average is 69. And that's a more appropriate number when it comes to this type of thing, like test scores that there aren't many outliers there. I mean, you got the one side, and you got the other side. The median is a bad choice here. Okay. If I want to talk about spread, I wouldn't use either of those. I have to choose something else. The mode of this data set, that's what that says at the end there. Here's another data set. And now they talk about the mode. But once again, this is a bad measurement. Yeah, 98 is the mode. It's the one that shows up most often. But don't try to use that for center or average, because it doesn't represent the data set. It's not the best representation when there's a large spread like this. So the mode is affected by spread. The mean, it's affected by the outliers, extreme values. And the median is kind of affected by spread too. Okay. So we just touch a little bit on spread because we need it for the box plot. So the biggest minus the smallest, that's called the range. The upper, I don't know why they call it all this. Just the highest minus the lowest. The highest value, if you want to call it max, let's call it that. Max minus min. I think that's the best way to say it. That's what the range is. So the range being 35 minus 20, that's how they get 15 there. I don't know why that dot's there. Okay. Alright, so that's called the range. It's a measurement of spread. It's a bad measurement of spread though, but it is a measurement. And what we're going to do is we're going to get the median, since it's 10 values, 2, 4, 6, 8, 10. Since there's 10 values, there's 2 in the middle. Take the average, 26.5. That's the median. And then what you do is you take your data now and split it into 2 halves. You got your upper half, 27 on to 35, and your lower half, 26 on to 20. And so from the upper half, you go and calculate the median there. And from the lower half, you go and calculate the median there. It's these two numbers that help you get what's called the interquartile range. We take the median of the upper half is called Q3. I gotta wait till next time to tell you why it's called Q3. Something about quartiles and percentiles, but we gotta wait for that. The median for the bottom half is called Q1, and you subtract them to get what's called this, for short, IQR, interquartile range. It's your middle 50% of the data. The middle 50% of your data ranges through 6 different values. If you take the interquartile range and give that at the same time that you give the median, then you'll know the middle number and you'll know the middle 50%. It's like a better combination. And it's used to find the box plot. We're only a few numbers away from being able to make a box plot off of a data set when we've gone this far and found the median and Q1 and Q3. Questions about that? Alright. So the box plot, there's a 5-number summary. I just told you what 3 of them were. The median, Q1 is the lower quartile, it's called. Q3 is the upper quartile. And the other 2 numbers that make up the 5-number summary, the 5 numbers that you need for the box plot, the other 2 numbers, we've seen them too, the max and the min, the largest value and the smallest value. So you have your 5 numbers now, all from this last slide here, or I guess the last 2 slides. Max being 35, min being 20, median being 26.5, that's 3 of our numbers, max, min, median, Q3, and Q1, they make up our 5-number summary. Put them in order. Min, Q1, median, Q3, and max. They're the 5-number summary, and they help you make the box plot. You make a box that goes from Q3 to Q1. Wherever the median falls, you put a line in the box. You put whiskers that go out to the max and to the min. It's a box plot. Okay. And it's the width of the box, how long the box is. That's the IQR. So those are the 5 numbers in the 5-number summary. Okay. You got your min point, you got your max point, you got your bottom 25%, your top 25%, your 50 percentile, and you make a box off of that. You draw whiskers out to the min and the max. This is actually the box plot for that data set. Make sure you have some kind of a scale so people can tell what the numbers are in the data set, what the 5 numbers are from the scale. That's it for that. Okay. So if you give a box plot and you put these dots, then just from the dots you can tell what the numbers are. This guy has to be the max. This guy has to be the min. This guy right here is Q1. This guy right here is Q3. And right here then is the median. The minimum is 0, the maximum is 70. The median is 20. Q1 is 10 and Q3 is 35. One last thing, just because it's tied to the box plot, it's called an outlier. Remember we said about outliers earlier, but now we have a mathematical way. Like before, we just said this thing kind of stands out from the rest of the data, so we call it an outlier. We said that, but now we can actually nail it down and say mathematically when something's an outlier. These two are, all the numbers in this data set, they're so packed together, there are no outliers there. But if you add something very, very small comparison with the rest of it, or something very, very big, then those guys are the outliers from what we said before. But we have a better way now to mathematically say they're outliers. Yes, they stand apart. So if you go by the stand apart definition, widely separated definition, then they're widely separated. But we have a way officially of saying it using the IQR, the interquartile range. It says that find the IQR. I'm just going to write it on here. Find out what the IQR is. Pick that number, right? That's Q3, take away Q1 from before. Find out what that is. That's some number. And then take 1.5 times that, whatever that number is. Take it and multiply it by 1.5. This gives you some distance. This number here will be some distance that you're going to add to Q3 plus that distance, and you're going to take it away from Q1 minus that distance. And these will be sort of your boundaries to your outliers. Anything smaller than this is an outlier. Anything bigger than this is an outlier. And anything smaller than this. Okay. We'll do it for that data set. But that's the math. That's basically what it is to mathematically say what an outlier is. Okay. What's underneath here is just you put an asterisk in the box plot. You don't, when you draw your whiskers, don't draw your whiskers out to those outliers. Instead, put asterisks on the outliers and draw the whiskers out for to where the non-outliers are. So here's a data set. What does it stand for? In 2004 Summer Olympics, this is the top 20 countries in the medal stand. I'm assuming, I guess, gold or maybe total medals. Probably total medals. So, yeah, definitely total medals. Okay, so total medals earned in the 2004 Summer Olympics. There's the data set. Those are the 20 countries. Forget about the countries, just focus on the data set. And we're going to make a listed smallest to largest, I guess up and down like this. Let's find a 5-number summary. We have 12 is the men, 103 is the max. There are 20 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So right here would be the two middle numbers, numbers 10 and 11. Halfway between those is the median, 28.5. Max is 103. Mean is 28.5. The minimum is 12. Then we need a Q3 and a Q1. We didn't say this. If you have an even number... Oh, what happened? Sorry. I clicked on something I shouldn't have done. If you have an even number in your data... If you have an even number in your data set, when you go to split it upper half and lower half, you have to include those ones that you ended up using for the median. Those end up being included in your upper and lower half. When it's an odd number, you just throw that middle number out. But here, those get thrown in, and so now you have 10, and so numbers 5 and 6 help you get Q3 and Q1. We'll take an average here and call that 18. Take an average here. What's halfway between that? What's the distance there? That's 9. That's 11. That's 11, so 6.5, so 5.5, so 42.5. Okay, so those are our 5-number summary. Not that we're going to make a box plot, but while we're at it, might as well get all of them. What we really need is just Q1 and Q3 to talk about outliers. But while we're at it, let me just give them to you. So we have 12 for the men, 18 for Q1, 28.5 for median, 42.5, and 103. Okay, so that's the same thing that we just had there, median, Q1, Q3. So what do? You take and you subtract. IQR is Q3 minus Q1. Q3 minus Q1. Find IQR, which is 24.5. Don't leave it like that. Multiply it by 1.5, and you get that distance, 79.25. That's that distance. What do you do with that? Take your Q1 and subtract that distance. Take your Q3 and add that distance. So if you do Q1 and subtract that, you're in the negatives. Negative 18.75. Yeah, I believe it. No, that's not right. Is that right? Oh, I'm sorry. That number's wrong. Okay, good. 1.5 times 24.5. 36 and something like that. 36.25. Thank you. So you add that 36.75 to Q1. That's what they did. Taken away from Q1. That's how they got that number. Add it to Q3. What was Q1? Q1 was 18. 18 take away that is negative 18. And 42.5 add on that is your 79.25. Anything smaller than that, which isn't happening, right? You're in a negative. Anything bigger than this, though, is an outlier. Anything bigger is an outlier. And yes, we have not only the United States with the 103, but there's also was it Russia had 92? Alright, sounds good. That's it. Alright, so your test will be over all of that. Chapter 9 and 10.1, 2, and 3, but only this part of 10.3. You can have the whole time if you need it. I'll open up the beginning for questions if there's any last-minute questions. You can actually email me a question if you have it over the weekend. If you try some of the web assignments, try some of My Math Lab and have some trouble, you can email me. I think there's a Ask Your Instructor feature. Yep. The attendance, just real quick, as you're walking out, put an initial next to your name, but don't initial next to your buddy's name. I caught someone doing that in another class. Don't do that. All right, see you.